Okay, this is question 6. Okay, we've got to start by sketching the graph of y equals 4 minus x squared, indicating points where the graph crosses the coordinate axes. So that means both x and y intercepts needed. So your x-intercept will be when y is 0 and your y-intercept will be when x is 0. And in terms of the shape of the graph, this is two transformations applied to the graph of y equals x squared. So you know what y equals x squared looks like. We've got multiplying by minus 1, and then we've got adding a 4. So make sure your graph looks convincing, and if you've got a graphics calculator, of course, you're laughing. But make sure you solve all the equations and get all the intersections with the axes. Okay, then this second part, okay, time of doing the video, this is finding a volume of revolution, which we haven't done, so don't worry too much about that. But part B you can do all of. So we've got to sketch the graph of the same thing that we had here, but the modulus of it. So you need to think about a graph that goes below the x-axis. If you have part of a graph that maybe looks like this, okay, then the modulus sign will leave the positive bit alone, but any negative part of the graph will get reflected in the x-axis. So we'll get a bit like that. Okay, make sure, watch your curvature, make sure it curves the right way, and make sure we have a nice sharp cusp here. So that's your graph. Then we've got to solve modulus of 4 minus x squared equals 3. Well, any equation with a modulus in it, the modulus either will do nothing at all, so it'll look just like this but without the modulus, or the modulus will have an effect, and the only effect that the modulus can have is swapping the sign of everything inside it. So if the modulus does have an effect, then we're going to get a minus 4 plus x squared equals 3. And therefore you get two equations for this. Okay, two different things could equal 3, both quadratic equations, but very easy quadratics, and so both of them potentially lead to two values for x. So make sure you get all four solutions. And then hence or otherwise solve the inequality. Well, hence actually refers to both of these. We know where this equals 3 from dotted 2. If you draw on the graph together with the graph of y equals, so your graph you sketched, if on a copy of that sketch you draw the line y equals 3, then we know that should cross the curve, the modulus graph crosses this line at potentially these four places. However many values for x you got, that's how many intersections there are. And then we need to choose the parts where the modulus graph is less than 3. So where the modulus graph is below the line, those bits of the graph you need to shade, and then you need to use your knowledge of where they actually intersect, where they're equal, to work out the endpoints on your ranges of a solution. And you do have an example very like this in your notes as well, so I hope that helps.